Good day, everyone. My name is Goddan. In today's class, we'll continue on our topic, measures of central tendency. Like we said in our previous classes, we said measures of central tendency is a way to find the center of a data. That is one single number in the data that can be used as a means of measurement for other data. Now, and we said the three major types of measure of central tendencies are the mean, the median, and the mode. We already looked at the mean, we already looked at the median, and today we're looking at the mode, right? The mode is the most occurring number or data most occurring number in a data, or the number with the highest frequency, the number with the highest frequency. So if I have a data, for example, say I collect the age of students in a particular class, and then I got their age to be 15 years. 15 years. I got the age of about 10 students in a particular class. The first student is 15. The next 15 years, the next student is 14 years. The third student is 13 years. The fourth student is 12 years. The fifth student is 10 years. The sixth student is 15 years. The seventh student is also 15 years. The eighth student is 10 years. The ninth student is 12 years. And then the 10th student is also 15 years. Now, this is the data collected, right, from 10 students. How do I find the mode of this data? The mode of this data is the data that occurred the most. You see, you can decide to rearrange, just like we did for media, arranging either in ascending order or descending order. Like we said, ascending is arranging from smallest to biggest, while descending is arranging from biggest to smallest. Whichever way you arrange, you will get your answer. So I'm arranging in ascending order. So I have 10 first, 10 occurred twice, 12 occurred twice also, 13 occurred once, 14 occurred once, and then 15 occurred 4 times. So we have 15, 15, 15, and 15. If you look at it, you realize that 15 is the number that occurred the most. So we say that the mode is equal 15. So in a situation where we have this kind of data now, look at this. We have 15 years, their age grade. We have 14 years. We have 14 years. We have 12 years. We have 10 years. We have 15 years. We have 15 years. We have 10 years. We have 12 years. And then we have 14 years. If you rearrange, you see that 10 occurred how many times? Twice. So we have 10 and then we have 10. You'll notice that 12 occurred how many times? Twice. Also, we have 12, then we have 12. Now, 14 occurred how many times? 1, 2, 3. We have 14, 14, and 14. And then 15 also occurred how many times? 15. 3 times. We have 15, 15, and 15. Now, if you look at this set of data, 14 and 15 occurred the highest, which means we have 2 numbers that occurred the most. Now, which of them is our mode? Very simple. In a situation where you have more than one mode in a data, that is, we have 2 numbers that occur the most, then it is called a bimodal. Now, that means that a data can have more than one mode. It can have multi-modes. So if a set of data has 2 modes, then it is called bimodal. Bimodal. If it has 3 modes, it is called, the set of data is called trimodal. That is, it has 3 modes. You see, don't stress yourself. Once it has more than 3 modes, it is called multimodal. So that goes to say that there can be more than one mode in a set of data. So if you ask me what is the mode of this particular set of data, we say our mode is equal 14 and 15. Now, this is sweet because this is the mode of ungrouped data, right? But what happens when we have larger number? Remember I said grouped data is used most often when we have larger set of numbers, right? So once we have larger set of number data, what do? We group them in class. So instead of working with them one after the other, so we group them. Say for example, if this is our class, now let's say we have numbers from 10 years old to say 20 years. We took the age of students in a particular secondary school. So, and then their ages are between 10 years to 20 years. But we took the age of, let's say, 300 students. Now, so we can't imagine, we can't work with 300 data. That would be too much. So what do? We group them in class. So we say between 10 to 12 be in one class. Between 13 to 15 now, right? Be in one class. Between 16 to 18 be in one class, and then between 19 to 21 be in one class. So let's assume we have students aged from 10 to 21 years, right? Be in one class. Now we now take their frequency. So let's assume this 10 to 12 occurs 70 times, and then 13 to 15 occurred 80 times. Now 16 to 18 occurred 90 times, and then 18 to 21 occur 60 times. So those the number of times this age occur is their frequency. So ages between 10, 11, and 12 are grouped as one class. So once we begin to see 10, 11, and 12, all of them have been grouped together to this one class, and that is all of them occurred 70 times. So now, how do we find the mode of this kind of data? Because remember, we've grouped them in one class. How do we know if it is 10, if it is 11, if it is 19, or if it is 20 that is the mode? Because they've been grouped in class, but then we must find their mode. It's a very simple thing, right? We use the formula mode equal capital letter L plus open bracket F1 minus F0 all over 2F1 minus F0 minus F2, then times C. Don't get scared. Don't be scared about this formula. I'm going to break it down and I will explain. Just like we did in the median, L is the lower boundary for of the modal class. So now, since we are working on mode, so the class we will work with will be the modal class. That is the class that has the highest frequency. So that means that our mode, to find our mode, we use the class that has the highest frequency. So our L is the lower boundary of the modal class. So this is the modal class. The modal class is 16 to 18 because 16 to 18 has the highest frequency, right? Remember, we can find our lower boundary, right? Lower boundary. How do we find our lower boundary? And of course, in case you want to also find your upper boundary, I said it in the last class. Now, the lower class boundary and upper class boundary, what class boundary generally, what it helps us to do is that it helps us close the gap between the upper class and the lower class of any two class. Now, if you look at the upper class in between 10 to 12, the upper class is 12, while the lower class for the next class is 13. The difference between these two is 1. Now, divide their difference by 2, that's 0.5. Now, you see this 0.5, to get the lower boundary of each class, subtract 0.5 from the lower class. This will give us 9.5. Upper boundary, add 0.5 to the upper boundary. This is 12.5. The same thing for each class. Subtract from lower boundary. This is 12.5. Add to upper boundary. This is 15.5. Subtract from lower boundary. This is 15.5. Add to upper boundary. This is 18.5. Subtract. This is 18.5. Add. This will be 21.5. You will now notice that there is no more distance between the upper boundary and the lower class. Upper boundary, lower class. Upper class, lower boundary. I mean, there's no difference. So that's what class boundary helps us to do. Now we are working, we say L is the lower boundary of the modal class. So this is what we are working with, the lower class. That's 15.5. So our L is equal 15.5. Now we have F0, F1, and F2. Very simple. In the order they came, F0 is the frequency before the modal class. F1 is the frequency of the modal class. Now, the frequency before the modal class is what? This is the modal class. The frequency before the modal class is 80. So our F0 is 80, while our F1 is what? 90. So the frequency of the modal class, which is F1, is 90, whereas the F2 is the frequency after. So you see, L, lower boundary of the modal class. F0, frequency before modal class. F1, frequency of modal class. F2, frequency after modal class. Frequency after modal class. And what's that? The frequency after modal class is what? 60, which is what? 60. Our class size, which is C, C is what? Class size. What is our class size? If you look at each class, 12 minus 10 is 2, right? 15 minus 13 is 2. 18 minus 6 is 2. 21 minus 19 is 2. So our C is equal to. So which is equal to. Can you see? We already gotten our parameters. So we can now find the mode using all of these parameters. So we say the mode is equal our L is what? 15.5 plus F1 is 90. That is 90 minus F0 is 80 over 2. F1 is 90 minus F0, which is 80, then minus F2, which is 60. Then we have times 2. Of course, according to board mass, you do what is in the bracket first. So we have is equal 15.5 plus 90 minus 80 is 10 over 2 times 90 is 180 minus 80 minus 60, then times 2. This will give us 15.5 plus 10 over, now 180 minus 80 is 100. 100 minus 60 is 40. Then we have times 2. 0 cancel 0. This will give us 15.5 plus 1 over 4 times 2. So we cancel out, we have 2. So what do we do? This is equal 15.5 plus we have 1 over 2. Of course, this is over 1. Take your LCM, right? This is 2. 1 through 2 is 2. 15.5 times 2 is, that's 31, right? Yes. 2 times 5 is 10, 0 and 1 times 5 is 10 plus 1, 1. And times 1 is 2 plus 1, 3. So we have 31 plus 2 through 2 is 1. And then 1 times 1 is 1. This gives us 32 over 2. Now, 2 we cancel out, we have 1 and 6. So we have 16. It means that the mode for this data is 16. It means that if we pieces this, right? If we pieces this class the way they are, 16 occurred the most amongst all of the number between 10 and 21. So our mode for this group of the group data is 16. I hope you enjoyed the class. Please do well to like, share, and subscribe to our channel. Until I come your way again, bye for now.